In this lesson, we'll be covering the Hackerrank medium-rated algorithm, climbing the ladder. And as usual, let's try to understand what the question is asking as well as what we are provided, and then dive into figuring out the algorithm. Okay, so this question states that we have an array of ranked scores and a player with an array of their own scores. And this ranking system operates with a dense ranking, which means that even though there are 4 scores, there will only be 3 rankings because 90 and 90 are equal. So 100 will get the ranking of 1, 90 and 90 will each get the ranking of 2, and 80 will get the ranking of 3. And essentially this question is asking, what will the player's ranking be as they score? So first they score 70. That puts them at the bottom of this list. The ranking will be 4th because he will get first, he and she will get second, and he will get third. And then our player will score 70 and pop them at the bottom of the list. Next go around in the game they play, they score an 80, ties them for third, so that will return 3. Next go around, they score 105. They wind up besting the whole rank list. They would get first. So if you scroll down, there's a good example of this. They use a chart and they pop a name onto each score. So our player, in this case, player would be equal to Alice. So here's the first go around. Here's the ranking before Alice does anything. Then Alice scores 5. It puts her on the bottom of the list. She gets 6th. The algorithm should return 6th. Next score, she gets 25 points. That puts her in 4th. You'd want to return 4. 50 gets her tied for 2nd. And then 120 gets her up to 1st. So here's... yeah, that's it, really. So I think we can now get to work. All right, yeah, we will pop over to Replit and start to code. So I've copied over the ranked array from the example as well as the player array from the example. And I'll be writing it out step by step and then kind of cleaning things up as we go. So first things first, what is one of the issues that you can see immediately in our ranked array? Well, you can see that we're working with rankings, but rankings can't really be evaluated how they're indicated in the question if we have duplicates. So in Python, we don't want a duplicate for 100. We just want 100 to show that 100 is the first place score. We only care about place here. We don't care about the actual number of outcomes that we have. So how can we get rid of the duplicates in this array? Well, we can take ranked and we can perform the set function on ranked. And then we can go ahead and print our new, well, that's not what we want. We can go ahead and print our new ranked array, or rather it's not an array, now it is a dictionary. So we'll go ahead and run that just to show you guys what we're working with. See, the ranked array has been converted into a dictionary that has selected for all the unique integers within the array. So now you will notice that it's no longer in the descending order. I think I left out that in the question, the ranked array will always be given to you in descending order, and the player array will always be given to you in ascending order. So we want it to be put back into descending order, so we can do 2 things. Now we've got a dictionary. We can take that dictionary and set it back to a list. And then we can take the list and perform the dot sort function on it. And to actually get a list sorted in descending order, you have to write reverse equals true. If you don't do reverse equals true, it will set it to the ascending order. So now we will go ahead and print ranked just to make sure that we are getting what we want and see what we're working with. Okay, great. So it goes from the dictionary to the descending ordered array. Okay, so we will get rid of you. And we could clean this up. Let's go ahead and clean it up. We'll consolidate all of that code into a one-liner. Really just a best practices kind of thing. So we can do basically everything what we just did, but type it in reverse. So you will sort the list that has been set. Okay, and then we've got to go 2 parentheses, I believe, comma, and reverse equals true. And then we will go ahead and print ranked, and we will comment this out. All right, let's see if that works. Awesome, works. So I'll leave this commented out just so you can kind of keep track of what we did there. It's a little bit more complicated to look at it in the one-liner form. And then we're going to want to manipulate our player array as well. You'll see later, but what we want to do is sort our player array in descending order. So we can actually do, yeah, we'll write it the same way as we did for ranked. Sorted player reverse equals true. Okay, and then we'll print our player. Great, that came out great. And we will again print our ranked. I think it'd be better to keep track of ranked as well as we're working through this problem to really understand what's going on. Okay, great. So now we will start looping. Not immediately, but we'll set some variables up so we can start looping. So what do we want? Well, we will set a variable of L equal to the length of the ranked array. And we will set a variable of J equal to 0. And J will represent our ranked position. And you'll see that more as we work through the problem. We'll also set an answer variable equal to an empty array, and we will store the rankings in there as we loop through our arrays. So what do we want to loop through? We want to loop through the player array because we want to take the score that the player got, and we're going to want to output or add to our answer array where they are ranked. So we can do that using a range. We'll do for n in range length of player. That's going to take us all the way through our player loop for the values of n. And we will actually want to write a while loop. And the reason for that will become more and more clear as we work through the problem. But so let's go ahead and set up the while loop. We'll want J to stay less than L. We never want to go beyond the index position of the available index positions in our ranked array. It wouldn't be possible. And while the value of player at n is less than ranked of J. Okay, So while J is less than L and player at position N is less than ranked position J, we're going to want to increase J plus 1. And then we will go ahead and answer dot append J plus 1. Okay, so what just happened? We'll do some printing, but first we're going to talk through it a bit and see what's going on. So for N in the range of length player, what would the first N be? The first N would be 0. So player N, what is player 0 equal to? Well, we're looping through our play array, and player N of 0 is equal to 120. So great, we have selected player, we've selected this 120 for our player. Is that less than ranked J? What's J equal to? J is set at 0. What is ranked at index 0? Ranked at index 0 is 100. So is player 120 less than ranked 100? No, it's not. So we will not add 1 to J, but we will append J plus 1. So what was J? J was 0. We will append 1 to our answer array. Okay, what happens next? Well, we finished this loop for N equals 0, so N will go up to 1. J will stay 0 because we didn't change it as we went through this loop last time, because player of N was not less than ranked J. So now that N is 1, what values do we have? Well, we're comparing player of 1, player index position 1, which is the value is equal to 50. Is that less than ranked J? Yes, it is. So J will get 1 added to it. And we will actually stay in this while loop. We will keep looking at J. J has increased by 1, so now J is 1. Is player position 1 less than ranked at position 1? No. They are equal. So we will not add to J again. J will stay at 1, and we will go through the next iteration of our N loop. Okay, what's next? N will be equal to 2. J is at 1. So player of N equal to 2 gives you 25. J of 1 gives you 50. This 50 position. Is 25 less than 50? Yes. We will add 1 to J and move through our array. Okay, so we added 1 to J. J will now be equal to 2. That puts us here in the array, in our ranked array. Ranked array position 2 is 40. We're still here with N. Is player N less than ranked J? Yes, it still is. So we will add to J again. We'll be comparing this number to 25. Is it less than? Yes. We will go ahead and get out of this while loop and append J plus 1. Okay, so I hope you're following. I hope this makes sense. I know it's tough. It takes a little bit of thinking. Go for a walk, think about it, keep printing things, keep thinking about it, take a nap. If you're not getting it, I'm sure you will get it if you just stick to it. But we will first go ahead and do some printing All right, so again, let's start looping and let's start walking through it. So first iteration of the loop, n will be equal to 0. J has been set equal to 0, so that's where we'll start. Player of n at n equals 1. Oh, I'm sorry, I just skipped. So n equals 0, j equals 0. Player of n will be equal to 120 because position 0 in our player array is equal to 120. Ranked position 0 will be equal to 100 because this is ranked position 0 right here. What happens there? Player of n is greater than ranked of j. So we skip the while loop and we will append j plus 1 to our array. And here, we print that here. We skip the while loop because it didn't meet the conditions of our situation, so we move into the next iteration of our n loop for our range. N goes up to 1, j stays at 0. Player of n equals 1 is equal to 50. Ranked of j equal to 0 is still 100. We get that same value because we're still here in our ranked array. We print j here because we have increased j by 1. Why have we increased j by 1? Well, because this player value is less than this ranked value. It met the condition for this while loop, went in and added 1 to j. And we stop after adding 1 to j because the next loop would be equal. It wouldn't be less. Okay, so then we take j, we add 1 to j, and we append that to our array. And what does this mean? This means that in this list of rankings, 50 is the second highest score. 50 and 50 would be tied, and they would both occupy position 2. So that's what that that's what that number represents, the rank in that ranking array. Okay, so we append because we made it out of our while loop with our j value of 1. We added 1 to the j value of 1 to get this 2. And then we go through the next iteration of our n loop. N is equal to 2. J is still equal to 1. Player at position 2 is equal to 25. We've made it to this third position in our loop, in our player array. Ranked at j equals 1 is equal to 50. Player n is less than ranked j, so j will increase by 1. Okay, what happens next? This j is increased. This j is now 2, which means we're going to evaluate 40. Is 25 less than 40? Yeah, we add another 1 to our j. Okay, so now j equals 3. What happens? We compare player n. Player n is still stuck at the same number. J has been increased by 1. J is now 3. We look at this 20. Is player n less than 20? No. We've made it out of the loop. We append j plus 1 to our array, which is this number here, 4. Okay. We made it out of the loop. We go to our next iteration of our n loop. N is equal to 3. Player of position 3 is equal to 5. The value of ranked position j, which is equal to 3, is 20. Is 5 less than 20? Yes. J goes up by 1. We now evaluate 5 versus ranked position j, which is now 4. What's ranked position j of 4? 1, 2, 3, 4? Is that correct? 0, 1, 2, 3, 4. Okay, sorry, we're comparing it to the 10. Is it less than 10? Yes. We append that to the array and we add 1. Okay, there is one thing left to do. So we have found where all of these rankings would fall, but we actually want to reverse them because the player scores their lowest score first, and then their next lowest, and then their next lowest, and then, of course, in this array, it would be the highest. So, what we're actually going to do is take our answer variable. We're going to print our answer variable, our answer array, in reverse order, which can be completed by writing parentheses, parentheses, -1. That means we're going to count backwards from the end of our array, and let's see what we return. Perfect. That is our last return right there, or our last print. We can now, I've got this consolidated in my VS Code off screen, so I will take that, head over to Hackerrank, copy and paste it. Oh, I included the function definition. Let's not include that. Okay, there we go. If you glance over it, you'll realize that it is the exact same code we just wrote, and perfect. We pass both of our sample test cases. Let's go ahead and submit it. Test against all the test cases and all pass. So I hope you understood what we just did. Really, all we did was move through the ranked array as long as the number we were considering was less than the ranked number. So we moved through that array, and then we took that index and we added 1 to it and appended that to our answer array. Thank you so much for watching. I hope this made sense. If it didn't, go take a walk, go think about it, go take a nap, think about it in your sleep. It will click, I promise. Keep writing this out. Write every line and then print every line if you're not following. And even if that doesn't help, just keep doing it. It will click eventually, I promise. Just keep doing it. I believe in you. Thank you for watching. Please, if you enjoyed, hit the like button. This may have frustrated you. If it did, that's okay. You'll come back and hit the like button later. And of course, please subscribe. I'll be covering a new algorithm as frequently as I can. And hope you have a great day. Thanks for watching.